Hello everyone, and welcome to our 9.5, 9.6 inverse trigonometry notes. And so last week we covered finding the side lengths that were missing using trig. Now we're going to look at how you find angles. So obviously we have three angles in a right triangle. One of them is 90. We don't have to find it. It's already there. But once you've got a right triangle, you can find either of those two acute angles using trig. So with trig, we can solve for unknown angles. So to do so, we're going to take the inverse of a trig ratio. So let me kind of show you that on the calculator. I keep trying to put this picture on here so you can see it. To find the side lengths, we did what I call normal trig. Just sine, cosine, and tangent, those basic functions. Sine, cosine, and tangent. Those are the buttons we worked with. But I want you to notice what is written above those buttons. So above sine is sine to the -1. That's called sine inverse. And so to make that happen, to make that pop up on your calculator, it's in light blue, so that reminds you have to click this light blue button first. So you click the second, you click the sine button like normal, and inverse sine will pop up. Same thing for inverse cosine. So, oh goodness, same thing for inverse tangent. So these are the buttons you're actually pushing. So you're still pushing sine, cosine, and tangent, but it's the inverse function that's popping up above it. Okay, so inverse sine, inverse cosine, inverse tangent. So you'll click the blue button, and then you'll click the normal sine, cosine, or tangent, and it gives you the inverse. So we're going to be working with those buttons today. So you will need a calculator to do this. Again, because we do not use our phones on the ACT and because we do not use our phones on assessments, we want to get used to using these scientific calculators. All right, so whenever we're looking at this right triangle, how do I know it's a right triangle? Because boom, it contains a right angle. So we have a little symbol right here you might have never seen. This little symbol looks like this. That is going to be the theta symbol. Call that theta, T-H-E-T-A. I have a math teacher friend and her dog's name is Theta. And so this is a symbol that we use to represent angles often. And so we learned our operations the other day. We learned that the sine of the angle is equal to its opposite over its hypotenuse. We learned that the cosine is equal to its adjacent over its hypotenuse. And we learned that tangent is opposite over adjacent. So we're going to continue to be working with that. However, now we're going to be looking for finding the actual angle. And so in order to solve for this actual angle, we want to, right now it's the sine of theta. We want to do the inverse sine. So sine to the -1 of both sides, and that makes theta be alone by itself on one side. But then that becomes the inverse sine of opposite over hypotenuse. And then we have the inverse cosine of adjacent over hypotenuse. And then we have the inverse tangent of opposite over adjacent. So we're going to be able to use our calculators here, so we're not really going to have to cross multiply. We're going to let our calculators do all of the work for us. So we're going to be using our inverse functions. So sine inverse, cosine inverse, and tangent inverse. And it's going to be all of these normal things that we're used to, but we're going to be doing the inverse of all of those things. So the way you know you're going to use this inverse trigonometry is anytime you're trying to find an actual angle. So it says use a calculator to find the angle measure, round to the nearest degree. So if the tangent of x, so that x is going to represent the angle, if the tangent of x is equal to 2.0035, of course that's a decimal, how do we know what x is going to be equal to? Well, x is going to be equal to the inverse tangent. You take the inverse tangent of both sides, and then x is by itself on one side, and we take the inverse tangent. So on my calculator, I'm going to click second tangent, so that second button, and then TAN, 2.0035. And that is going to give us about 63.474. So what is that rounded to the nearest degree? They want it rounded to the nearest degree. Of course, the nearest degree means to the nearest whole number. That's just what they told us on this one. That is going to round to about 63 degrees. 63 degrees. Okay? We can also do that with cosine, and on this other problem, we're trying to find if the cosine of x is equal to 7 over 15. So this is a fraction. This can also be done with a fraction. So x is going to be, you take the inverse cosine of both sides, and that is going to be inverse cosine of 7 divided by 15. So second cosine, 7 divided by 15. You can also do this with a fraction. Rounded to the nearest degree is going to be about 62 degrees. 62 degrees. Okay, so how do you do that in a triangle? We have our steps, just like we did the other day when we were finding unknown side lengths. And this is just kind of like an overview. We don't have to rely on these every single time. You'll get used to it. The first thing we're going to do, just like before, is to identify some side lengths that are known. So last time we had one known and one unknown. We need to have two known side lengths. and to find the angle measure that you're wanting to solve for. So identify how the two known side lengths relate to the angle that we're solving for, opposite, adjacent, or hypotenuse. And then you're going to identify which trig ratio to use, whether that is inverse sine, inverse cosine, or inverse tangent. We know that we're going to be using the inverse because we're solving for an angle measure. Solve for the angle measure by using the inverse of the trig function you selected in step 3. And so what is the angle that we're solving for? In our picture, the point of view, the perspective is theta. So I know I'm looking for an angle. I know I'm going to be using inverse trig. So the angle I'm solving for is theta. I have two known sides. I have the 14 from the theta. That is going to be its opposite. So the 14 is opposite. I have another known side. The second one is going to be the hypotenuse, HYP. That's obviously across from this right angle, so it's the hypotenuse. So I have two knowns. One's opposite and one's hypotenuse. The other one is blank. Now, if I had one there, I could still use any of the combinations, and I could use sine, cosine, or tangent. But because I have opposite and hypotenuse, that is going to be my inverse sine button. I know I'm going to end up using inverse sine. Okay, so let's actually go through and do the work of that. We're going to say that the sine of theta, sine of theta is going to be equal to opposite over hypotenuse, so that's going to be 14 over 20. 14 over 20. So I know I'm going to end up doing the inverse sine. So that is going to be the inverse sine of 14 over 20. I'm just showing y'all how we got that to solve for, so eventually you can just jump straight to the step. That angle is going to be equal to the inverse sine of 14 over 20. So inverse sine, 14 divided by 20. Again, make sure that your calculator is in degrees. That's going to, they say to round it to the nearest tenth, to the nearest whole number. So to the nearest whole number, that is going to be about 44 degrees. 44 degrees. Obviously, that's rounded, so if this is about 44, we could find the other one if we wanted to. It's also going to be acute. You would just do 180 minus 90 minus 44. The other angle would be about 46 degrees. Okay? All right, so I did want to point this out. Whenever you are typing this in, inverse sine, you click, what was that, second sine 14 divided by 20. You want to make sure that it says on your calculator DEG down here. We're working in degrees, not in radians. Okay? So make sure your answer makes sense. It should be an acute angle, which of course we know is going to be less than 90. Every single time it should be less than 90. Okay, let's do this again. What am I solving for? Again, I'm solving for theta. That's my point of view that I'm approaching this triangle from. So I'm solving for theta, looking for an angle. I have a known side across from it. That is going to be its opposite. I also have a 4 centimeters, which is going to be adjacent because the hypotenuse is blank. So my known side is the 25 is my opposite. The adjacent is my 4. What trig function goes with opposite and adjacent? That is going to be the inverse tangent. We're going to end up using some inverse tangent. So if I want to know what is my angle going to be equal to, my angle is going to be equal to the inverse tangent of the opposite over the adjacent. Opposite is 25, adjacent is 4. So I type that into my calculator. Second tan, 25 divided by 4. That gives me an angle of approximately, to the nearest whole number, 81 degrees. So the other acute angle would be about 9 degrees. Okay, and that does look really close to a right angle, just the way that it's drawn. I know that we don't always rely on that, but we do want to make sure our answers make sense. All right, it says solve for the indicated values. Round the sides to the nearest tenth. I do think I got rid of the sides on here. So we're going to round the angles to the nearest degree. Now, sometimes we might have you round angles to different things like the tenth or to the hundredth. But on these, we're going to round it to the nearest degree, which just means the nearest whole number. The nearest whole number. Okay. All right, so the hardest part is just figuring out which trig function it is. How am I approaching this triangle? Through the lens of x. So if you want to change that to a theta, you can. I like to do that just to remind myself, hey, what am I looking for? I like the x's to be our sides, and I like thetas to be angles. It just reminds me what I'm looking for. So it's easy to change that if you'd like to. Okay, so from that angle, I have two numbers on here. I have a 20, which is going to be the hypotenuse of this triangle. And I have the 9, which is touching this, so it's going to be the adjacent of that triangle. What trig function goes with opposite and adjacent? It's going to be inverse cosine. Okay, cosine is adjacent and hypotenuse. So theta is going to be equal to the inverse cosine of adjacent over hypotenuse. That's going to be 9 over 20. You literally just type that straight into your calculator. So I actually think that this is easier than solving for side lengths because it's less steps. So how many degrees is that approximately? About 63 degrees. I'm going to change that to approximately, which means that that other angle would be the complement of that. 90 minus 63 would be 27 degrees. You could use Pythagorean theorem if you really wanted to solve. Eventually, we're going to solve for all missing pieces of triangles. You could use Pythagorean theorem to find that leg. We're not doing that today. We'll come back to that later this week. Okay, again, what am I looking for here? X is an angle, and whenever that's an angle, I like to change that to a theta to remind myself, hey, I'm using inverse trig. Inverse trig. So from the angle, I have my 17 is going to be my opposite. It's my OPP. And then I have my 11, which is going to be my adjacent, because I do not have the hypotenuse labeled. What goes with opposite and adjacent? We know that's going to be some inverse tangent. So this angle is going to be equal to the inverse tangent of the opposite, 17, over the adjacent, 11. And you get to go straight to your calculator. Inverse tangent, 17 divided by 11. You get approximately 57 degrees. That is an acute angle. I'm going to change that to an approximately symbol just to show that we rounded it. It was not exactly 57. All right, 2 more. We want to find the measure of angle B. So the reason I did this one is I wanted to make sure that you could identify where that's at. So where's angle B? That's this one right here. So it didn't have a value there. So I'm going to throw a theta right there. From our angle, I have the 2. 2 is going to be our opposite. That lies opposite the theta. And then what is the 3? The 3 is going to be our hypotenuse. It's opposite the right angle. So that's our hypotenuse. It is touching the angle, but it's not the adjacent one because it's the longer one. So what goes with opposite and hypotenuse? That's going to be some sine. So I'm going to say that this theta is going to be equal to the inverse sine of its opposite over its hypotenuse, which is 2 over 3. What I love is you get to go straight to your calculator at this point. 2 divided by 3. Okay, 41.8, so that's going to be approximately 42 degrees. About 42 degrees. All right, last one, I did give you all some decimals on this just to show you they're not always whole numbers. So there's my theta. That's what I'm solving for. I know I'm solving for an angle. So from that angle, I have the opposite piece, 19.4 OPP. And I have a hypotenuse in this right triangle. 19.7 is going to be my hypotenuse. So what trig function is that? That's going to be sine. Sine goes with opposite and hypotenuse. But because I'm solving for an angle, I know I'm going to be using some inverse trig. So it's going to be the inverse sine of 13.4 over 19.7. Again, we want to round this to the nearest whole number, so you just type that in, inverse sine of 13.4 divided by 19.7, and you get about 43 degrees. 43 degrees. Okay. I did want to mention that you want to make sure that your answers are making sense, and so had we gone the other way and accidentally flip-flopped our opposite and our hypotenuse, you can do that in your calculator. You'll get a domain error, so you'll know that you did something wrong. It's got to be opposite over hypotenuse and not hypotenuse over opposite. So if you ever get a domain error, that means that you've set up the fraction wrong, or you're typing something in wrong, or maybe you've labeled something on the triangle wrong. You can notice I label it every single time. Okay, so we were just rounding all of these, and I think that is how it is on your homework on the back as well. Directions, solve for the unknown angle, so you're just doing this entire first section in your calculator. And then you're having to decide the actual function, the inverse function for 7 through 10. And then I do have a challenge on here. Before I teach you solving the entire, all the missing pieces in a right triangle, I want to see if you can do this. So try these out. If you do not feel 100% on those, that's okay. We're going to get there. It's about progress, not perfection. But I want you to see what you can do with those 2 triangles. And then we'll do more of that later this week. I hope you are having a fabulous day.